Hello everyone, welcome back to another Unity tutorial. So last week I didn't post a video, so okay, I'll post another one this week, probably. Okay, last time, let's see where we stopped. As far as I remember, we've made the spread for the bomb, the animation for the spread, but now it still goes through walls, so that's what we're going to try to fix. So let's open the bomb script and check our script here for spread, and that's what we have. Origin, position, we instantiate the beam, and that's all. Okay, so in order to detect that we are hitting a wall, first we need a way to know that. We will specify what a wall is by using a layer tag. A layer, not a layer tag, okay? So it will be a serialized field, private, and this is of type layer mask. A layer mask is to specify which layers among the layers that we have. Let's see what's a layer first. If you click a game object, wait for it to compile, you see here we have a tag and we have a layer. These are the layers, and you can add layers as many layers as you want, up to 32. Okay, so layer mask will show you these layers and you pick which one you want to use. We will see that in a minute. So layer mask, and we'll call this wall layer. Okay, we will go to the spread function or method, and we will create a raycast. Let me explain what a raycast is. So for example, suppose let's see how to explain this in a good way. You have a square here, you have another one here. You want to detect if they are close by, for example. So let's get this, change the color. Okay, the red one will create a ray cast starting from its center and going this way, for example. We give it this distance. Okay, so a ray cast is a ray that you shoot from a specific point, which is this one here, and you give it a direction. We gave it this direction, and you give it a distance. So this is the distance that we gave it. The recast will return if it hit something from this origin point to this destination point. If it had hit something, it will return it. Simple as that. Okay. So what we want to do is we will return if the position where the beam will be added, or where the bomb is, from where the bomb is, and we send a raycast until the range of the bomb, and if we hit a wall, then we ignore what's past that wall. We'll see how we do it. It's fairly simple when we do it, but while talking it might be a little bit tedious, so we'll do raycast hit 2D, and we will call this one wall hit because later on we will need this for another thing. So wall hit equals physics 2D dot raycast, and what does it take? We will give it the origin point, we will give it the direction we're going in, and we will give it the distance, which will be the range of this bomb. Why do I have to? Oh, this is system bit range. Okay, we'll give it the range, and we will give it the layer that we want to check against. So it will be wall layer. This way, it will only return objects that have this layer specified, and will ignore anything else. Now we will do a boolean hit wall. So did we hit a wall? This will be wall hit dot collider this will automatically convert to a boolean if it's true. If it exists, then it's true. If it's not, then it's false. Then we will start. If wall hit, let's see what we do. I wonder, should we right now add the other stuff that we will use, because later on we will add boxes and all. So I guess we go on and add them right now. It's the same thing that we were going to add, so why not? Let's call this layer wall, and we'll call this layer breakables. Okay, then we will go to the tile set, or tile map here, the one that contains the walls, and we give it wall. And now we will go to the bomb prefab, and you see here we have wall layer. We will call this, we will select wall. Go back here and I will add another layer for breakables. I'm not adding them together in the same layer because the behavior will be slightly different, because on a wall we don't want the explosion to appear on the wall but on a breakable. We want it to appear on the breakable but not past it. Sorry. So breakable layer and go back here. Sorry, I'm sick. We will create another recast. We will call this one breakable hit. We'll use a breakable layer here. And we will also have another one for hit breakable. Make sure you change this. A lot of people make mistakes, so I do and copy paste because they forgot to change something. And now let's delete this. We can keep it, but let's delete it and start anew. So if we hit a wall and we hit breakable. So what we're going to do in this case, we will get the distance. So if wall hit dot distance is less than breakable hit dot distance, this will tell us which one we're going to collide with first, because it depends which one is closer to the bomb. We can have this situation here, like when the bomb is here and we have a wall, and right next to it we have something breakable, we say like a box. So if we recast like this, we need to know that the wall is closer to the bomb than the breakable, because in that case the beam will stop here and won't go all the way to the breakable. That's what we're going to do now. We will detect which one is closer. So in that case, if wall is closer, then this will be false because we will not collide with this. Otherwise, this will be false because we won't be colliding with it. I don't want to have curly braces if we have only one instruction. Semicolon missing here. There is more elegant way to write this, but for now we can just do it. And next we are going to deal with each case separately. So if hit wall, if we hit a wall, first thing, what we're going to do is detect the distance. So the distance that we have hit. If come on, if wall hit, not hit wall this time, not the boolean variable. We want the wall hit, this one here, the raycast hit to d dot point minus origin dot magnitude. This gives us the distance if it is less than or equal to 1. What does that mean? So it's the first block right next to the bomb in the direction we're going in. It depends if we are going right, left, up or down. That's determined by the direction here, but after this it doesn't matter until we start instantiating. For now, this means that it's the first block right next to the bomb. In that case, we won't be instantiating anything and we will return immediately. Because it's the block next to the bomb. We won't show a beam on it and we won't show anything past it. Now, if that's not the case, we will create a vector 3 to hold the position, which is going to be wall hit dot point minus direction times 0.5. So what that means is that let me check something real quick. I'll just copy this and I want to see the positions that we had previously. Yeah, it's not the same thing. I'll explain why. Okay, let's go back here. Okay, so the new position will be the wall hit dot point minus direction times 0.5. So let's instantiate this. Instantiate. Where is our method? Instantiate beam. Oh, did I write instantiate wrong? Yeah, I write it wrong. Let's fix this. Instantiate beam, and we will give it a position, a direction, and this will be the end beam. We'll pass through here. Now, for the rest of the... Come on, why am I typing wrong? For the rest of the distance, because this is the furthest point in the explosion, which will be the end beam. Now, from that point and back to the bomb, we will declare I as our iterator, starting at 1, and I will be, while I is less than wall hit dot point minus origin dot magnitude. Well, we can maybe store this somewhere. It would be better. So let's create a float here, call it dist, and it will have that. To avoid recalculating it multiple times. And this would be dist too. While I is less than the hit distance, what we're going to do, we're going to increment I. Also, in order not to add another non-end beam, another regular beam on the end position, we will do -1 here and plus I. I plus or plus I, the difference is really insignificant, but this just saves a little bit of memory. Okay, we will call this again, but this time with false. Simple as that. Now, this is if we do hit a wall. Let's go test this. And let's see how it behaves. So make sure you're in a position that you will hit a wall. And we hit a wall on the left side. On the top and bottom, nothing will show up because the wall is right next to the bomb. And on the right side, we don't have a wall and we haven't treated this case yet. Let's try here. Oh, I think we have a problem. Yep, we do have a problem. The beams do not appear to shoot correctly. So let's fix that. Okay. Then let's see what we have here. Oh yeah, sorry, my bad. I have blindly copy pasted this. It's not like that. It's not a fixed position. The position will be minus I times direction. So this will offset by 0.5, which is to show the end beam, because it starts with a 0.5 offset from the position of the raycast. Let me quickly show an example here. Come on. Let me quickly show an example. I'll explain why that position is offset a little. Let's put a bomb here. Okay, don't care about this. We will fix that. I haven't typed it correctly, but this is what I want to care about. So look at this area. We had the bomb. Let me change the color to something contrasting with green. Okay, we had. Oh, why am I using that? This. Okay, we had the bomb here. This is better. And we did a raycast in this direction. We hit this point. We do not hit this center point. We hit the point on the collider. But for us, the sprites we have their center in the middle, their pivot in their center. So we need to offset it by direction minus the direction times 0.5. So we go back in this direction, and the distance is only half a square. So we are positioned right where we want, in the center of square, to show sprite correctly. Okay, I think that's comprehensible enough. If you don't understand something, just tell me in the videos and in the comments, sorry. Yeah, it was that I forgot to put position here. Okay, that should work. Why is this showing an error? Because I had vector 3 while it should be vector 2. Okay, now if we try it, I'm sure it will work. And then we will do the same for the cases where we hit a breakable and when we hit nothing. So let's put this here, and you see it shows up correctly. Okay, perfect. Let's get going now. If we hit a breakable, so else if breakable hit or hit the breakable, what we're going to do is fairly similar, just little small difference. We're going to do the same thing for the calculating the position. We will get the position, but instead of stopping there, because let me do another example. Waiting for it to compile is so maybe I should disable reloading domains. Okay, so for example, we have that. We have the bomb here. Let me see a better place. Okay, we have the bomb here, and let's say we have a crate here. So that's a crate, and we are going to do a raycast in this direction. The point that will be returned is this point here. But in the case of a breakable, unlike a wall where the explosion cannot spread there, we want to stop it at the level of the breakable. It doesn't go past it, but we want to show it on the breakable itself. It will be shown here. You see my point? So we want to show it there and not beyond it. In order to do that, it's simple. Instead of offsetting the position this way by 0.5, we'll offset it this way by 0.5. That way, we will end up on this row of sprites. If it's not clear, tell me in the comments. I'll try to explain it more. Okay, so the position this time is offset by plus direction times 0.5. We will instantiate the end beam as we did before, and we will copy this, paste it, but there will be a small difference here. So this, we will redo this again. You see that I haven't treated this case if distance is less than 1, if it's the first block, because in that case I still want to show the end beam on the breakable itself. So I won't do that. And here we have breakable here to calculate the distance. And while I is less than that distance, we will instantiate it. In this position, this stays the same because going from the end beam back to the bomb, we will offset by minus I times direction. Now, the last case, if we didn't hit everything in the raycast, it's very simple. Let's take the position, which is going to be on vector 2 again, but this time it will be dependent on the transform of the bomb. So we will cast the current position to a vector 2 transform dot position plus dir times range. So we will go to the maximum range this time. This is the end position of the beam. We will instantiate the beam like this. Nothing changes here so far. We will declare I. Let's try another thing just for beginners so that they know different ways to do stuff. I starts at 1, and while we can do the same for loop, it perfectly works fine, but just so showing different ways for beginners, we will do a while loop this time. And let's do this. Position minus this here. We can also... okay, nothing. The position minus the current transform magnitude, so the distance from the last beam we've created to the bomb. If it is greater than 1, what we're going to do is instantiating the beam. So, and we will offset the position a little bit. So position minus equals I times direction. So we will go back towards the bomb by 1 unit times I. I prefer writing it I times direction. And we will instantiate this. So make sure that you do this correctly and change this to false. Okay, let me check. Did I change everything? I didn't forget something to true. Okay, perfect. Let's try it. And let's see how long has this been so far. Whoa, 23 minutes. I think we want to what we talked about last time. When bombs explode near each other, they force each other to explode. You see now it works correctly. If I put one here, one here, one here. Yep, everything works. Well guys, thank you for watching this far into the video. Like it if you like it, don't forget to subscribe, and see you next time. Goodbye.